The next example, and one of the last examples we're going to look at, is sine of 2 theta. I'm going to work with sine of 60 degrees. Now we know from the outset that sine of 60 degrees is the same as root 3 over 2. Sine of 60 degrees, sine of 2 theta, sine of 60 degrees is the same as sine of 2 times 30 degrees. Now sine of 2 theta we know is equal to 2 sine theta cos theta. But it's not theta in this case, it's 30 degrees. 2 times sine of 30 would be 2 times 1 over 2. Cos of 30 is root 3 over 2. 2 times a half is 1 times root 3 over 2 is just root 3 over 2, which is the exact same thing as sine of 60. This is just an application of that. Most of the time though you will have it in the form sine of 2 theta, which then becomes 2 sine theta times cos theta. The final example I'm going to look at is that of cos 2 theta. Again, I'm going to use cos 2 times 30 degrees. Now cos of 2 times 30 is the same as cos of 60, which should equal a half. Now we know that cos of 2 theta has got 3 different distinct identities. The first one being cos squared theta, so in this case cos squared 30 degrees minus sine squared 30. Cos of 30 is equal to root 3 over 2, but it's cos squared, so it's root 3 over 2 squared minus 1 over 2 squared, which is equal to 3 over 4 minus 1 over 4. 3 minus 1 is 2 over 4, which is the same as 1 over 2, which is exactly the same thing that we know it should equal. Now you'll notice that for cos 2 theta there are 2 other identities, the one being 2 cos squared theta minus 1, or 1 minus 2 sine squared theta. The reason for that is that sine squared theta this here could be also, or rather could also be 1 minus cos squared theta, and cos squared 30 degrees could also be 1 minus sine squared theta. So it could go either way, but all of the answers would come to the same thing of a half in this case, because we used 60 degrees. We are now going to look at solving identities, or rather proving that the left hand side is equal to the right hand side. There are 3 rules that I want you to follow when doing these type of calculations. The first rule is convert everything to sine and cos. Specifically, look at tan. Take all of your tans that are in your equation and convert it to sine over cos. Rule 2, start with the more difficult side. Usually you have either the left hand side, which is quite drawn out, is equals to a very small expression on the right hand side, or the other way around. Start off with the difficult one and try and simplify that. Also, convert all of the double and compound angles to smaller simplified angles. And thirdly, be creative. Manipulate either of the sides of the equation or both sides of the equation if you need to, and try new things out all the time. Take 1 for example, maybe convert it to sine squared theta plus cos squared, or something like that. But be creative, try different things all the time. The example I'm going to use says prove the following identity, and the identity reads 1 minus cos 2x multiplied by 1 plus 1 over tan squared x divided by 1 over cos x multiplied by sine of 2x. And I need to prove that that is equal to 1 over sine x. Now, I'm going to start off with the side that looks most difficult. Most people would agree that the left-hand side is the more difficult side, so I'm going to start with that. 1 minus cos 2x, I'm going to turn that into 1 minus the first cos 2x is equal to, there are three possibilities. The one possibility is cos squared x minus sine squared x. The other possibility is 1 minus 2 cos squared x, or 1 minus 2 sine squared x, or 2 sine squared x minus 1. Although there are three possibilities, I always like to start with cos squared x minus sine squared x, because this one is the easiest to manipulate further, or rather it's the most noticeable. So assume that there's only one real identity for cos 2x as opposed to the three that do exist. 1 plus 10 squared, 1 plus 1 over 10 squared x. Now think about this. 1 over 10x is the same as 1 over sine x over cos x, which is equal to cos x over sine x. Right? The same reason 1 over 2 over 3 is equal to 3 over 2. So 1 over 10 squared x will be the same as cos squared x over sine squared x. It's all of that divided by 1 over cos x, let's leave it for now as 1 over cos x, multiplied by sine 2x is equal to 2 sine x times cos x, and that's over 1. The reason I'm doing that is because it's multiplied by that. Now, the next step I'm going to take, I'm going to leave this for now as 1 minus cos squared x plus sine squared x. The reason it became plus is because a minus times a minus. And it's all of that multiplied by 1 plus cos squared x over sine squared x. Isn't 1 the same as sine squared x over sine squared x, common denominator? That means that that will read sine squared x plus cos squared x all over sine squared x, and this is our numerator,